The first lightning talk we're going to have is going to be Rob Kenefeck, Dockerizing GUI apps. And over to Rob, and the timer starts now.
Thanks, Ben. So first off, I want to say thanks to Alexa for the introduction earlier with his speech. I'd already said I wanted to do this lightning talk, and then he started talking about what it was like to do containers on the desktop. So that was a great little lead into this. I'm Rob, I'm here from Specsavers, and I've just thrown together a couple of slides to talk you through one of the things we're doing at the moment. I'll just move the... So the challenge that we were trying to solve, and I'll explain how we solved it afterwards, was the autonomous management of our desktops in our retail stores. We've got nearly 400 stores across Australia and New Zealand, and we were about to roll out a major point-of-sale upgrade in New Zealand. We needed to manage those clients, and we needed to keep some sort of consistency with them. We had all kinds of problems that we'd had from our old operating systems. We used to use Red Hat 5, we've moved on to Red Hat 7. We had problems with our service desk managing them, with users installing their own bookmarks and changing things on the desktop and customizing their settings, so it wasn't a consistent approach to how we did things. Our users are also a bit scared of technology. They're sitting in a retail store. They don't want to log in each time that they come to do something on the computer. So we needed to come up with a kiosk-like solution for them, but still maintain some of the security. I said it's a retail point of sale, so they can be walking up and down through the store, and they'll sit down at whichever computer is most convenient for them. They don't want to log in too many times. We also needed an easy upgrade path, so we wanted to go from what we had to something new, and to continue being able to deliver new things, be that new browsers because we were putting in a cloud-based system, or whether that was new features for the operating system that the users would need to use. Which kind of leads me into why contain. When we started going through our problem solution, we decided that containers would be the best way to deal with it. We could have done it so many other ways, and I'll show you our stack in a second. But containers give us all these desktop solutions, and everyone else here is probably using them on a server. So you've got something that runs the same every time when you launch it. Your users should have limited control to change it, and anything that they do change should get reverted back. We also like things that are easy to support, so that our small team of service desks can support things, and we needed reliability so that we could be confident that in our distributed stores, everything was running as we'd expect it to. And if it failed, we should be able to just throw it away and start up again. There was a talk earlier in the conference about hardware. Hardware is boring. I completely agree. Hardware is really boring now. We just want to put the right stuff on the hardware and use any hardware that's available. We also were looking to decouple component upgrades, so we want to be able to upgrade our browsers without having to upgrade everything else on the system as well, swap in an older version of the browser without being at risk. So this is our stack. We use Puppet to do all of our orchestration. We have two different types of nodes in our stores. One of them is a server, which provides a squid cache for all of our Docker images. We run across a small bandwidth internet connection, so we don't want to be pulling down images all the time. Puppet then manages our Docker stack on the clients with Firefox, Chrome, OpenOffice, and all of the applications that a user would need. They launch these by going to a shortcut on their desktop. So they'll click on the desktop icon, they'll launch Chrome, and to them, they're just launching Chrome. They have no idea what's going on in the background. When they close that Chrome session, all the passwords that they typed in get thrown away. All of the cookies that got stored get thrown away. Everything gets thrown away except for the specific items that we've allowed them to store. So if they wanted to download a file, that file wouldn't be thrown away. They're storing that into a mounted image. It's different to whatever else I see when everyone talks about Docker and what Docker is doing for them and how they're orchestrating it. Our images don't change very frequently, so as we come up with a new version of the Chrome container, maybe every 3 months. If OpenOffice releases some updates that we need to implement, then we can release that as a piecemeal part. For us, it works really, really effectively, And to the users, they get very frustrated about not being able to save their passwords, but we maintain the security that we're looking for. To make all of that happen as a desktop application takes a lot more behind the scenes than I can talk about in a 5-minute talk. But we're mounting the X socket in so that... and that's the timing, yeah. All right, thanks.
Thanks very much, Rob. Quick round of applause.